determinant of a matrix. The goal of this video is to show us how to find the determinant of 2 by 2 and 3 by 3 matrices. We shall not go beyond that. So, if A is a square matrix, I guess you understand or you know what a square matrix is by now. So A is a square matrix. Just to remind you, a square matrix is a matrix that has equal number of rows and columns. So if A is, for example, a 2 by 2 matrix, then A is a square matrix. And if A is a 3 by 3 matrix, A is a square matrix. But if A is a 3 by 5 matrix, A is not a square matrix because A will be having 3 rows and 5 columns. Therefore, the number of rows and columns are not the same. Hence, A is not a square matrix. Now, why is this important? It is because we only define determinant of a matrix for matrices that are square. Okay, so we can talk about the determinants for a 2 by 2 square matrix, 3 by 3 square matrix, and generally for an n by n square matrix. So if a matrix is square, for example, matrix A is a square matrix, we can define what we call determinant of matrix A. And that determinant is a special number that represents that matrix. The importance and the usage of determinant of a matrix cannot be emphasized in the study of what we call linear algebra. Okay, but we shall not go deeply into that study for now. What then is a determinant of a 2 by 2 matrix? So we start with a 2 by 2 square matrix, Sm, 2 by 2 square matrix. Now we know already how a 2 by 2 general square matrix looks like. So A11, A12, A21, A22. In my previous video, I had explained already what the subscript mean. So A11 means this is the entry in row 1, column 1. A12 means the entry in row 1, column 2. A21 means the entry in row 2, column 1. And of course, A22 means the entry in row 2, column 2. Of course, this is our row 1, right? Row 1. This is row 2. This is column 1. And this is what? Column 2. Very good. So we want to find the determinant of this square matrix A. Now, to find the determinant of square matrix A, we would be writing A between 2 straight bars. So when we write A between 2 straight bars, this would mean that we are about to find a determinant of matrix A. If we don't want to write A between 2 straight bars, we'll write DET to mean determinant, and we'll write capital A. So that would also mean the determinant of matrix A. So how do we compute this? So to find the determinant of matrix A with these entries, the first thing we're going to do is to put these entries also within straight bars. So straight bars, A11, A12, A21, and A22. You observe that the brackets have also changed from these parentheses to what? To the 2 straight bars. So this tells us also that we are about to carry out to find the determinant of matrix A. If you recall also from the last video, there's a diagonal here which we call the main diagonal. This diagonal here, which is from top left to right bottom. So this diagonal is called the main diagonal. Another name for it is principal diagonal, is it not? Or just a diagonal. And the other diagonal is called the off diagonal. Now to find the determinant of matrix A, we'll simply multiply the entries of the diagonal, which are here. In this case, they are A11 times A22. Then we subtract, we now say minus the product of the determinant, rather the product of the entries in the other diagonal, or let's say the off diagonal. And those are A21 and A12 minus A21 and A12. So when you do this, what you found is the determinant of matrix A, and that is it. Okay, let us take 2 quick examples so we understand what we're saying. So example 1. Let me use the red pen to example 1. We have a matrix A here is given with entries -3, -2. So here is 3 and here is -1. So we want to find the determinant of matrix A. So determinant of matrix A is what we want. So from what we have said already, the determinant of matrix A, which is this, I put A between 2 straight bars, will be equal to, I put the entries again between 2 straight bars. So -3 here, 3, -2, and -1. So I recall that to get the determinant of matrix A, I will just multiply the entries of the diagonal and then subtract the entries of the off diagonal. Is it not? Okay. So that will be the main diagonal are minus 3 and multiply with minus 1, the diagonal entries. Then minus the other diagonal entries, 3 times what? Negative 2. So minus 3 times minus 1 is just 3, minus 3 times minus 2 is minus 6. So minus 6 times minus is plus 6. So what is 3 plus 6? 3 plus 6 is 9. Therefore, the determinant of matrix A is 9. And that is it for 2 by 2. Let's take one more. So let's say matrix B has the entries, say 2, 4, 3, and negative 1. Okay, so we want to find DET of matrix A. What does that mean? The determinant of matrix A. Okay, now we know what to do. So DET of matrix A is equal to, we place the entries of matrix A, within 2 straight bars. So this is 2, 4, 3, and negative 1. Okay, so and what do? We multiply the entries of the diagonal and subtract the entries of the off diagonal, right? So determinant of matrix A will simply be, the diagonal entries are 2 and minus 1. So 2 times minus 1. Then I'll subtract, and I'll say minus the entries of the other diagonal, 3 and 4. So minus 3 times what? 4. So that will give us 2 times minus 1 is minus 2, minus 3 times 4 is 12. So minus 2 minus 12 is what? Negative what? 14. So for the matrix B with entries 2, 4, 3, and negative 1, the determinant of matrix B, I was using A here, I beg your pardon. The determinant of matrix, what's wrong with me? I'm used to A. The determinant of matrix B is what? Negative 14. So you see that in the first example, the determinant was positive, and in the second example, the determinant of the matrix is negative. Of course, there's no problem with that. So we'll now launch into the determinant of a 3 by 3 square matrix, and we shall not go beyond that for now. So determinant of a 3 by 3 square matrix. So once again, let's write down the general 3 by 3 matrix, square matrix. So this is A11, A12, A13, A21, A22, A23, A31, A32, and A33. Okay, so the determinant of matrix A, I'm going to write determinant of matrix A is equal to, you know what to do? You put the entries of matrix A between 2 straight bars as follows. So we have this. Now, the good thing about a 3 by 3 matrix, determinant of a 3 by 3 matrix is this. Now we can find the determinant of this matrix A using any row of our choice or any column of our choice. Remember, this matrix has 3 rows: row 1, row 2, row 3. It has 3 columns: column 1, column 2, column 3. Now we can expand, we can find this determinant of matrix A using any row of our choice, and of course any column of our choice. And when we take examples, you shall see what we are doing. So now I want to take the determinant of this 3 by 3 general square matrix. So what do? We're going to now start. So that implies now we want to expand this using row 1. So I want to expand using these entries A11, A12, and A13. So we want to expand using those entries. Now, so we pick the first entry, this A11, and what we now do is we are going to delete all the entries in the row where A11 is found and in the column where A11 is found. Now remember or recall, A11 means the entry in row 1. So what's row 1? This is row 1. And column 1, what's column 1? That's column 1. So pretend for a second that those entries are no longer, existing. So what will be left? What will be left will be the determinant of A22, A22, A23, A32, and what? A33. That becomes a 2 by 2 determinant. So we're trying to reduce the determinant. Then, what's the next entry there? Remember row 1. So after A11, we have A12. So here the sign will be negative. We'll now say minus A12. We'll repeat the same thing we had done initially. So now we're going to, so let us erase this and have our matrix back. Good. Now we are here, A12. So A12 is in row 1. So we delete the entries of row 1. But now it's in column 2. So row 1 and column 2. So if we delete those entries in row 1 and column 2, we have a 2 by 2 determinant A21, A21, A23, A23, A31, and what? And A33. So what's the last entry in row 1? The last entry in row 1 is A13. So now plus A13. We repeat the same thing. So I take this off one more time. We are now on the entry A13. Now A13 is the entry in row 1. So this is row 1. I take it off. And column 3 and column 3. Take it off. So we now have a 2 by 2 determinant A21, A22, A31, and A32. Very good. So we have exhausted all the entries in row 1. We have used A11, A12, A13. I'll bet with the following signs. We use plus here for A11, so plus, for A12 minus, and then for A13 plus. I shall make more comment, I'll make more remarks on this sign. So what do you observe? You observe that the determinant we had here was a 3 by 3 determinant, and what we now have here is we have 2 by 2 determinants here in 3 places, alongside some numbers by the left to multiply by. What you see here, this determinant you see here, has a name. This determinant, these 2 by 2 determinants, which we got, from A11, is called the minor of this entry A11. So this guy you see here is called the minor of A11, which we want to denote as M11. So this is M11. So M11 simply means the minor of the entry A11. So this determinant you see here, which we got from A12, is the minor of the entry A12, which we want to write as M12. So this is the minor of the entry A12. And what you find there also, lastly, is the minor of the entry A13, which we want to write as M13. So what do we now see here? We now observe that the determinant of matrix A is simply equal to, expanded using row 1, is equal to A11 times the minor of A11, which is M11, minus A12 times the minor of A12, which is M12, plus A13 times the minor of A13, which is M13. So if we compute this, then we've gotten our determinant. Now, so I want to say these are 2 by 2 determinants, which you already know how to compute. So this will be A22 times A33 minus A32 times A23. Same thing here and there. So this is the formula for our 3 by 3 determinants. And this has been obtained using what? Using row 1. So if we decide to use row 2 to expand the determinants, the same thing will happen. Okay, so what happens in row 2? So let's assume we want to use row 2 for this determinant. Now, but before that, let us fix the signs. So you observe that here was a plus, and here was a minus, here also was what? A plus. So if I use row 2, we have to fix the sign. So I'll just give you a little trick here about the signs. So just take it as a remark. So remark. The remark is that now if you're expanding, through an odd row slash column, okay, odd row slash column, then begin with plus. You're expanding through an odd row or column, begin with plus. Now this holds true no matter how large the matrix is. For 4 by 4 matrices, 5 by 5, 6 by 6, whatever it is. So what does this mean? If row is odd or column. So if you want to expand through, the row, and you observe that the row you're using is an odd row or odd column, you begin with plus. This is what it means. Now, when I said row 1 is an odd number. So this is an odd row, okay? So it begins with plus. So that will be plus minus plus. The signs that follow here. Now, if you want to expand using an odd column also, column 1, is it odd? Yes, column 1 is odd. So what other, okay, let's finish with the row. So what other row is odd here? Row, this is 3 by 3, so row 3 is also odd. So row 3 will also begin with plus, minus, plus. That's the meaning. So let's look at column. So column 1 is odd. So column 1 will be plus, minus, plus. What other column is odd? Column 3 is odd. So that will be plus, minus, and plus. And the other one is that if you're expanding through an even row slash column, what do you begin with? You begin with what? With minus. So in this case, row 2 is an even row, right? So row 2 is an even row. So you begin with minus, so that will be minus plus, and the minus is already fixed. And what other row is even here? Just row 2, because it's 3 by 3 matrix. If it was 4 by 4, row 4 will also be even. Now same thing happens to the column. If you're expanding through an even column, then you begin with a minus sign. Let us see. Column 1, column 2. Column 2 is an even column. So you begin with a minus sign. So that will be minus, plus, and minus. So that's how we fix the signs on your determinant. So with this, you're comfortable. So you can expand using any row or column of your choice. You know how to fix the signs now, I believe. So here we had expanded using row 1. We can also expand using row 2 if you want. So you can expand using row 2. So expand using row 2. And now row 2 is an even row. So we'll now start to expand using row 2. This is our row 2, right? Good. So I'll just so the first entry there is A21. So we have A21. So A21 times what? Times the minor of A21, which is M21. Remember, it has to start with a minus sign. Row 2 is an even row. So we begin with a minus sign. So this is minus A21 times the minor of A21. Now what's the minor of A21? The minor of A21 is the determinant of, so you take off the row where A21 is found and the column where A21 is found. And whatever it is you're left with, let me take out all these ones so there will be no confusion. Whatever it is you're left with, okay, becomes the minor of A21. So what are we left with here? We're left with A11, A13, A32, A33. That's the minor of the entry A21. After that, so remember our sign, an even row. So this is minus, plus, and minus. You now take that off. I'll now take the next entry in row 2. What's the next entry? A22. So this is minus, plus, and minus. Don't forget. So this is plus A22 times the minor of A22, which is M22. What's the minor of A22 again? This is A22. Delete the entries in the row of A22 and in the column of A22, and you have that. And what's the last one? Last one will be minus, then minus the entry that is A23 times the minor again of that entry A23. So the minor of A23 will now be the entries. So you delete again the rows and column of A23. So this is A23 is in row 2. So you delete row 2 and column 3. You delete column 3. What is left? A11, A12, A31, A32. And that's what you have there. So when you do this, with this you have gotten a determinant using expanding through row 2. You can do this using row 3. You can do it using column 1, column 2, or column 3. You have the liberty and the choice to make. Okay, it's now time for examples. Example. Here we have matrix A, and that's a 3 by 3 square matrix with the following entries here. And we're asked to find the determinant of matrix A. And the first question is it possible to find the determinant of matrix A? The answer is yes. And why is it so? It's so because matrix A is a square matrix. And we have said already that we can only define determinant on square matrices. Okay, so with this we can go on. Now the next thing we want to ask ourselves is, should we expand using row 1, row 2, or row 3, or column 1, column 2, column 3? Okay, now the best answer here actually is to expand using either column 2 or row 3, and I'll explain to you why very soon. But for now, let us stick with what you've learned already. So we want to expand our determinants. So we want to expand our determinant. Okay, expand using, let's say, row 1. So we're going to expand using row 1. So you know what to do. So row 1 is row 1 and even or odd row 1. 1 is odd. So when it is odd, what happens? You remember the signs will be minus, plus, and minus. So we pick the first entry, which is A11. In this case, A11 is 1. So determinant of A simply means determinant of 1, 2, 1, 3, minus 1, and 2, 3, 0, and 1. So in fact, this should have been here, not there. It should have been here. So row 1 is in row 1. It's an odd row. So this is minus. This is plus rather, minus, and plus. Okay. Now, determinant of matrix A is equal to, so what's the first entry here? A11 is 1. So it's 1 in this case. So what do? A11, this entry is in row 1. So we delete the row 1 entries and column 1 and delete column 1 entries. So what do we have? We now have a 2 by 2 reduced determinant. So we have -1, 2, 0, and 1. What will be the next sign? Will be minus. So minus. So we now clean up our line and see what is left. So we are now at the next entry, which is 2. So -2. So again, the entry 2 is in row 1. So we clean the row 1 entries, and column 2. We clean up column 2. What is left? We are left with 3, 2. We are left with 3, 2, 3, and 1. 3 and 1. And the last one will be what? We'll have the sign plus. So plus 1, right? So let us take this one again off, so there'll be no confusion whatsoever. So we have plus 1 into 1 is in row 1. We take the row 1 element out, or entries, and it's in column 3. We take column 3 entries out, and that would be, what is left is 3 minus 1, 3, and 0. Okay, so this is A11, and it's 1 times its minor, minus 2, 2 and times its minor, and then 1 times its minor. And what are these? These are just 2 by 2 matrices, which you already know how to compute the determinants. So this will now be equal to 1, this one here, into, this is 2 by 2. So what do? Multiply the diagonal entries and subtract the off diagonal entries, right? So -1 times 1 is -1, minus 0 times 2 is 0. -2 is here, into 3 times 1 is 3, minus 3 times 2 is 6, plus 1 into 3 times 0 is 0, minus 3 times -1 is -3. So -3 times minus becomes plus 3. So that becomes 1 into -1 minus 0 is -1, -2, 3 minus 6 is -3, right? And then plus 1, 0 plus 3 is 3. So this becomes 1 times -1 is -1, -2 times -3 is plus 6, 1 times 3 is 3. And what is that? -1 plus 6 is 5, 5 plus 3 is 8. Therefore, the determinant of matrix A is 8, a 3 by 3 square matrix. Now delete all this and look at this matrix once again. Now, if you are given this kind of matrix in exams condition and you're asked to solve for its determinant, it would be wise and advisable to expand its determinant through either column 2 or row 3. And why am I saying that? I'm saying that because I observe that my column 2 has a 0 entry, and of course this 0 entry is either in column 2 or in row 3, anyone. Very good. So the 0 entry is in column 2 or row 3. So I would like to expand using row 3, and you see why I'm saying that very soon. So let us expand this determinant again using row 3. So the next thing is row 3. Is it an odd or an even row? Row 3 is an odd row. So 3 is an odd number. So row 3 is odd. So what happens? Our rows, you recall, we said that if we have odd row or column, begin with what? A plus sign. So here we begin with plus, minus, and plus. So we start with the first entry, which is 3. So that will be, let me write it just by the side. So determinant of matrix A again, now using row 3. Okay, so now expanding. We are now expanding using row 3. That will now become, so plus, so 3 is here, 3. So what is the determinant after? So 3 is in row 3. So we take row 3 elements out, and then column 1, we take that out. So what is left? We are left with 2, 1, -1, and 2. Good. This one is minus 0. So minus 0. What is left? We go back here and repeat. So 0 we take off, that's in row 3, and column 2, take that off. What is left is 1, 1, 1, 1, 3, and 2, 3, and 2. And then what the next one is plus. So plus 1, there's 1 here. We come back and repeat our guy. So here 1 is in row 3, column 3. What is left is 1, 2, 3, and -1. So now compute the determinant. So this is 3 into 2 times 2 is 4, minus 1 times 1 is minus 1. That becomes 4 plus 1. This is 0, right? Therefore, whatever this is, when you multiply by 0, it remains 0. So we can as well just delete this term. Is it not so? It is. What is left here is plus 1 into 1 times minus 1 is minus 1 minus 3 times 2 is 6. That is minus 6. So that gives us 3 into 4 plus 1 is 5 plus 1 into minus 1 minus 6 is minus 7. That is 3 times 5 is 15. 1 times minus 7 is minus 7. And 15 minus 7 is what? Is 8. What do we observe? We observe that we get the same value of determinant when we expanded using row 1 and using row 3. However, you should also observe that the steps using row 3 are shorter than the steps using row 1. And that has happened because of the 0 in that row. Because you observe that when we got to this point of multiplication, because we had a 0 here, whatever we had here, this would have been 1 times 2, that would have been 2 minus 3 times 0. And whatever that value is, it will always be 0 when multiplied by 0. So you observe that once you cite that you have a 0 somewhere in your matrix, either in a particular column or a particular row, it is advisable to expand your determinant through that row or column that has one or more zeros, because it will always give you shorter steps to your determinant. So I'll just take one more example to emphasize this point, and then we close the video at that point. So example 2, we have a matrix B, a 3 by 3 square matrix. We're asked to find the determinant of matrix B. Of course, it's possible to do that. But from what we have seen so far, you ask yourself, now you know already that you can find this determinant using any row or column of your choice. You can do it using row 1, row 2, row 3, column 1, column 2, or column 3. However, from the previous example, you have seen that sometimes it's easier expanding using certain rows. What do I observe here? You observe that row 1 has a 0. Have you seen that? So, and row 3 has no 0. Therefore, it will be easier expanding this determinant using row 1 than using row 3. Because you know what is going to happen at some point. Now, row 2 also has 1 0, somewhere. So if you expand using row 1 or row 2, you will get the same computational stress. But if you expand using row 3, it will involve more steps of computation. But I observe something. So I've seen now that it's easier to use row 1 or row 2, and row 3 will be dangerous. However, you get the same determinant. But let's look at it from the column angle. If I expand using column 1, there's no 0 there. If I expand using column 2, there's no 0. If I expand using column 3, there are 2 zeros in column 3. Wow. So I have 2 zeros in column 3. To me, the best column, to use in expanding this matrix should be column 3. Column 3. Because column 3 has, 2 zeros. So I'm saying here that it is always advisable, if you want to be fast, and get a determinant in a very short time. Once you find that there's a particular row or column that has more zeros, it is advisable to expand your determinant using that column or row, as the case may be. So here, we're going to expand our determinant here using column 3. Column 1, column 2, column 3. And why am I taking column 3? I've explained already. I can find many rows, or I can find 2 zeros on column 3, or in column 3 rather. So I could be column 3. However, I must fix my signs. So column 3 is an odd column. So remember, for odd columns, where do you start from? You start from what? Positive. So odd column, this is plus, minus, and plus. Don't forget that. Plus, minus, and plus. So you pick up the entries and multiply by their what? By their minus. So the first entry there is 0. So we put here 0. So determinant, let me write it down first. Determinant of matrix B is equal to determinant of 1, 2, 0, 3, minus 1, 0, 4, 2, and minus 1. So I'll put the signs again one more time. Plus, minus, and plus. So this will give us, so I pick the first guy, which is 0, 0, I delete. But there will be no point, because as long as here is 0, whatever I have here will be 0. So that is gone. Minus 0 again. I delete again. I've seen again that here is 0. No matter what I get here, I'll still get 0. Then plus. So this is plus, that is minus, so this is minus 1. And I'll delete the last one. So this is, I delete the row, which is this, and the column. And what do I have left? I have 1, 2, 3, and -1. This will be 0. This again will be 0. So what I'm left with is just this. So I now have -1 into 1 times -1 is -1, minus 3 times 2 is 6. And that will be -1 into -1 minus 6 is -7. So -1 times -7 is just 7. And that's the determinant of your matrix B. Very short. It's short because I've used the column that has more 0 entries. Now let us see what we'll get if we try to use another column or row entirely. Now let's see. Look at row 3. Now row 3 has no zeros. Okay, so let's use row 3 to expand. So we're going to expand now using row 3. So expanding now using row 3. So let's see if our determinant will be different. If it's different, then we're in trouble. Okay. Now row 3, let us fix our signs once again. Row 3 is an odd column, so we fix it plus, minus, and plus. Very simple. If you're using true row 2 is an even column, so that will be minus, plus, minus, just like that. And this can be done using no matter the order of your matrix. And you see this trick of using zeros here. If you have a large matrix, okay, that has zeros, in some rows and some columns, whoops, with this method or this pattern, you can easily find the determinant of a very large matrix. Okay, so having said that, let's go. This is going to be the determinant of matrix B is going to be, so we pick the first guy 4, we delete what we're going to have. So we delete the row and the column. What is left there is 2, 0, -1, and 0. This one is 2, so that will be -2. So -2. We delete again. So very fast. Let's be faster now. So we delete the row and the column. What do we have? 1, 0, 3, 0. The last one is -1. So this is plus, that's minus. Plus times minus is minus. So -1 into, again, we come here, delete the row and the column. And what we have is 1, 1, 2, 3, and -1. All right, let's compute. This will be 4 into 2 times 0 is 0, minus 1 times, this is 0, that is 0, minus 2 into 1 times 0, that is 0, this is also 0, wow, minus 1 into 1 times -1, 1 times -1 is -1, minus 6. So this is 4 times 0, this is 0, minus, this is 0, minus 1, minus 1 minus 6 is what? Minus 7. So that this is minus 1 times -7, once again, is 7. So what do we observe? We observe that we've gotten the same value for the determinant using, expanding via row 3 and via column 3. However, if you had used column 3, you wouldn't even need these first 2 steps. Okay, but here you would have done this first just to come and realize that you're having 0, at some point. So when you see your matrix and you have a 0 row or 0 column, I'm emphasizing it, please try to expand your determinant using such a row or column, with the fact that if your column is an odd column, the signs will be plus, minus, plus, and so on. If your column is an even column, the signs will be minus, plus, minus, and so on and so forth. I'll now give you a 4x4 square matrix, or 5x5 square matrix, and you try to see if you can find the determinant of such a matrix using this trick of finding the column or row that has many zeros. So as an exercise, I want you to compute or find the determinant of this 5x5 square matrix. Though what I've taught you is for 3x3, but I've given you a trick that should help. So let's discuss it. Let me discuss it rather. I observe here that let me see. Row 2 has 1 0 somewhere. Good. So row 2 will be a better candidate than row 1. Is it not so? Because row 1 has no 0 at all. So I know already that it will be more difficult expanding through row 1. So row 2. So if I'm expanding through row 2 is an even row. So what will be the sign? Minus, plus, minus, plus, minus. I guess that is clear. Or I can also see that row 3 has 2 zeros. So expanding through row 3 will even be better than expanding through row 2. I have 2 zeros here. So there will be less computational stress. I have on row 4, I have 2 zeros somewhere, 1, 2. So the stress of using row 4 and row 3 will be the same. They have the same number of zeros. Finally, I have row 4, and row 4 has just 1 0. So the stress of using row 4 will be the same as the stress of using row 2. Is it not so? But row 1 will be more stressful because there is no 0 at all. Let's look at the columns. Column 1 has no 0. Wow, I can't even dare it. Column 2 has 1 0. Better than column 1. I can try using column 2. Column 3, whoops, has 1, 2, 3, 4 zeros. Column 3 has a whooping 4 zeros. Therefore, this will be the most, in fact, this is the best column to use in expansion because you have 1, 2, 3, 4 zeros in a column of 5 entries. In fact, there is no better candidate than column 3. So I want to try out the expansion of the determinant of this matrix using expanding through column 3, and leave your answers in the comment section below. Please like this video and share to other persons. See you in the next class. Thank you and bye bye.